Good evening, everyone, students. Now, I would like to invite Prachi ma'am to continue the session.
Hello everyone. So how are you all? I hope you all can see my screen. So if you can see my screen, you just have to type Y in the comment chat, and then we will quickly recall whatever we have learned yesterday, and we'll do also see the question that I gave you. So yes, who all are there? So you all have to type Y if you can see my screen, and we'll quickly begin with the recall. So yes, so yesterday we started with the law of reciprocal proportion. So in that law, what we learned is in the simple language, if I have to put it in a simple language, then what it says is that if there is a element, common element, and it is forming a compound with two different elements. So here I have two different elements, which is hydrogen and oxygen, right? Which is hydrogen and oxygen. So if I see the compound that is formed by carbon and hydrogen, then the compound that will come to our mind will be CH4. We can take any other compound also. And if I look at carbon and oxygen, then the compound that is formed by the combination of carbon and oxygen will be CO2. Now, once I have got the compounds that will be formed by the combination of these different elements with one common element, then I have to see the mass ratio of the other elements that are forming the compound with the common element by keeping the mass of the common element same. And then in the next step, I have to see the compound that is formed by the other elements that were combining with the common element. Now here, this law says that whatever is the mass ratio of these two elements, then the mass ratio of the elements in the compound that is formed by these two elements will also be same, or it will be a simple multiple of that. And based on that, I gave you this problem. So, are you replying in the chat or are you texting me? So, yes, you have to reply in the common chat. So, yes, I can't see reply from anyone. So, are you people there? I can see that nobody is replying. So, yes, if you are there, mark your attendance, and then we will see this problem, how we have to approach the questions related to the laws of chemical combination. And there is a probability that you can get a question based on the law of reciprocal proportion. So if you are there, just mark your attendance, and then we will move ahead with this question, which is asking which among the following pair of molecules is following the law of reciprocal proportion. So yes, you have to. So you are sending the message to me, or you are sending the messages in the common chat. So what I have opened is the common chat. So please send message on that. So yes. So how do we solve this problem? How we have to approach this problem? So first, what we have to do is we have to pick the common element. So what I can see here is, yes, oxygen is common, right? And it is forming the compound with two other elements. And here I can see that we have nitrogen and we have hydrogen. So now I have to see whatever the third molecule I have, it should be formed by the combination of these two elements, which is hydrogen and nitrogen. Now tell me, can you see that this molecule is formed by the combination of nitrogen and hydrogen? Yes, the other compound that we have is formed by the combination of hydrogen and nitrogen. So yes, these pair of molecules, they will follow the law of reciprocal proportion. So I can just see Rakshita, where are other people? So you also have to mark if you have understood the first example. Now I'll tell you some other example and then you have to attempt rest of it. So let's suppose I have this. I'll pick up the third one, right? Okay, Gayatri. So here we have molecule which is SO2 and CS2 and SO3. So now let's see what is common element here. So yes, I have sulfur here. And with sulfur, in the first molecule, I have oxygen. And in the second molecule, I have carbon. What I have carbon, right? So now the third molecule should be formed by the combination of these two elements, which is the carbon, and it should be carbon and oxygen. So do we have the molecule which is formed by the combination of carbon and oxygen? So your answer should be no. Here we can see that the molecule is formed by the combination of sulfur and oxygen. So here for this, I can say that this is not following the law of reciprocal proportion. Now quickly tell me which among these five is following the law of reciprocal proportion. First, second, third, fourth, fifth. So among all of these, what are the options which are correct? So I have shown you how you have to approach these kind of questions. So first you have to pick the common element in any two molecule, and then you have to see whether the third molecule is formed by the combination of the other elements or not. So quickly, so you have to quickly tell me what is your answer. Yes, Rakshita. So we have Rakshita, Gayatri, Omkar, Jyoti, and Ashrita, right? So you have to tell me your answers. Yes. So yes, Gayatri says that the correct answer is first, second, and fifth, which is wrong. So I'll tell you what is the right answer. So the correct answer, the correct options are first and fourth. So the correct answer is first and fourth. So you also try it, and then again we'll come to this question, or you can remind me after the end of the session. We will again come to this question and see how these two options are correct and rest of the options are wrong. Now after this topic, what we have learned is we started with the atomic mass. What did we learn? We started with the atomic mass. So in that, what we saw is that the atomic mass will be because of the mass of the protons, neutrons, and electrons. Where I know that the mass of the electron will be very less as compared to the mass of proton and neutrons. So what I can write is that the atomic mass, the mass of an atom, it will be the sum of the mass of the proton and neutron. And in the starting, what was taken as the reference for measuring the mass of the compounds? So the reference that was taken was 1 by 12 into mass of 1 carbon 12 atom. Now there were many reasons to choose carbon as a reference. So yes, of course, things were tried with other elements also. For example, oxygen and hydrogen. Then there were certain problems with it. Then the scientific community, they came up with carbon 12 choosing as the reference. So this value, it was taken as AMU, which is atomic mass unit. Now the mass of all the elements were written as, so if I write for the atom of sodium, then it was written as 23 AMU. For oxygen, it will be 16 AMU. For nitrogen, it will be 14 AMU. Right? Now, we should know what is the relationship between AMU and gram. So what we have came up with is that 1 AMU is equals to 1 upon Na grams, where this is known as mole, and this is what we will be learning about in today's session. We will be learning about mole. Now, we know that atomic mass is the mass of one atom. So for oxygen, it will be 16 AMU. Now, if I want to write it in the grams, then how we will write? We will write 16 divided by Na grams. Similarly, we can write for nitrogen. So in AMU, the mass of one atom of nitrogen will be 14 AMU. For hydrogen, it will be 1 AMU. In the similar way, we can find out, as we can find out the atomic mass, in the same way, we can also calculate the molecular mass. So molecular mass will be for a molecule. For example, water, ammonia, or methane. So if I pick water, then it will be, the mass of the water will be because of hydrogen and oxygen. So 2 atoms of hydrogen and 1 atom of oxygen. So in that way, I'll get it as 18 AMU. Still the unit is AMUs. And here I am talking about the molecular mass. Now, let's suppose if I have ionic compounds, right? If I have ionic compounds, for example, if I have NaCl, if I have MgCl2, then in that case, we say that what we have found out is the formula mass. So for 1 unit, the word that we are using is formula mass for 1 unit, right? For 1 unit. Because NaCl can't be said as a molecule. It's an ionic compound, and how they arrange in the space is very different from when we are forming the compounds by the covalent bonding. So in ionic compounds, the structures are different, and in the covalent compounds, the bonding is different. So here, what we will say for 1 molecule, we will say that we have got a molecular mass. And for the ionic compound, what the word that we will use is the formula mass. Right? I hope this is clear. Now, quickly, if this is clear to you, type yes, Y, and we will move ahead with the new concept that we have to learn, which is mole. If this is clear, then we will move ahead, and everyone has to participate in the class. So if this is clear, just quickly type Y and we will move ahead. Yes, I am waiting for your replies so that I can start with the mole. Yes. So, mole. What is mole? So, as you know, for dozen, what do we use? We use 12, right? Or if I say couple, then it means 2 objects or 2 things. And if I say dozen, then you know automatically that we are talking about 12 items or 12 things. In the same way, 1 mole represents these many items. So it is in the same way how dozen represents 12, mole represents these many entities, these many particles. If I say in chemistry, these many objects, these many particles, which is 602 hexillion. Now, every time in my copy, I'll not be writing this long, right? I won't write 602 and then I am putting 21 zeros. So how can I write it? I can write it as 6.02 into 10 raised to the power 23. So how we can say, when somebody says 1 mole, then it means how many number of items do I have? I have 6.02 into 10 raised to the power 23 items. For example, if I say a dozen of banana, then you know that we have 12 banana. Now, if I say 1 mole of bananas, then that will be equals to 6.02 into 10 raised to the power 23 bananas. How big is this quantity? For example, if I'll take these many numbers of candies means the toffees that you eat, for example, a toffee like this, right? So if I'll take 1 mole of these toffees, then they will make up to the size of Earth. This is such an big number. So if I'll take a candy or what you say, a toffee of this size, and I'll take these many toffees, that is 1 mole of these toffees, then they will make up to the size of Earth. So this is such an big number. Whereas if I take 1 mole of sulfur, then what you will see is it will be a very small amount which I can keep here in a bowl. Or let's suppose if I take 12 grams of sulfur, right? That also is equivalent to 1 mole. So if I take 1 mole of carbon, 1 mole of sulfur, those substances, what I'll see is that they will be in very small quantity. Why is that? Because atoms, they are very, 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 very tiny, right? So that's why we required a value which we can use for denoting the amount of substance, because the atom is very small. So now, from now, what you have to do is take out the periodic table and take a look what is the mass given there. The mass that is given there in the periodic table is the molar mass. That is the mass of the 1 mole of those elements that you see in the periodic table, right? For example, for oxygen, it is 16. For sulfur, it is 32. For carbon, it is 12. That is the mass of the 1 mole of a substance. So how do we write 1 mole? So 1 mole is the mass. How do we write molar mass? So the mass of the 1 mole of a substance. Mass of 1 mole of substance is simply a molar mass. You can see the word here, molar. It comes from mole. Molar, mole. So molar mass is the mass of 1 mole of substance or 1 mole of particles. So here the particles, they can be molecules. Yes. So they can be molecules, ions, electrons, protons, electrons, whatever they are asking. They can give you anything. Let's suppose they say you 1 mole of water. So now when I say 1 mole of water, water is H2O. Now let's suppose I ask you how many particles of, or I say how many molecules of water is there. So if somebody is saying you 1 mole of H2O, then in that case it means that we have 6.023, or you can write 6.02 also, 10 raised to the power 23 molecules of water. What you have? 6.023 into 10 raised to the power 23 molecules of water. In the similar way, if somebody says you 1 mole of NaCl, what are they saying? They are giving you 1 mole of NaCl. Then that means you have 6.02 into 10 raised to the power 23 formula units of NaCl. Right? Now, if you are given 1 mole of helium, what does that mean? It means 6.02 into 10 raised to the power 23 atoms of helium. Correct? Because the smallest particle that you will find when somebody gives you helium will be a atom, right? So that's what 1 mole means. And the mass of this 1 mole will be known as the molar mass. Now, the other thing that we should know is what is the volume that is occupied by 1 mole of a substance. So if we have a gas, this is true for gases, this is true for gases. So now let's suppose I have the 1 mole of a gas, then the volume that is occupied is 22.4 liters, or in some textbook what you will see is nowadays that 22.7 liters. What is it? 22.4 liters, or else you will see 22.7 liters. Why are we getting the different values? So here the pressure, it is taken as 1 atmosphere, and then we are doing the calculations which we will further see in states of matter. So from there we find out these values, and similarly here the pressure we are taking 1 bar. So the details are not that important, but don't be confused, don't worry if you see 22.7 somewhere, because still the volume that is used is 22.4 liter, but don't panic if you see 22.7 liter. The difference is because the value of pressure at which they are calculating the volume. So one will be calculated at 1 atmosphere and the other one was calculated at 1 bar. So from here, what do we know now? That the mass of the 1 mole of substance is known as the molar mass, and the volume occupied by 1 mole of a gas is equals to 22.4 liters. So if somebody says 1 mole, if somebody says 1 mole, then automatically now you know that it is 6.023 into 10 raised to the power 23 particles. Now those particles, they can be molecules, it can be atoms, they can be ions, and it can be proton, electron, or neutron. So if this is clear to you, now we will move ahead to the things or the type of questions that we can get related to mole, mass, and the volume. Yes, if this is clear to you, just quickly type yes, and then we will move ahead with the problems related to 1 mole. Not related to 1 mole, related to moles. So moles is the unit which will be used for specifying the amount of substance. So now here I have a problem for you which I'll also solve, and then we will come to a common conclusion, right? So let's suppose we have 54 grams of water. What we have? We have 54 grams of H2O gas, right, in form of vapors, right? Now what you have to do is you have to find what is the number of moles. So how we have to approach this problem? So I know that the weight of 1 mole of H2O. So what is the weight of 1 mole of H2O? It is 18 grams. What it is? 18 grams. Now there is one other thing which you should know from here is, how did I get it 18 grams? From AMU, how did I go to grams? So now we want to, let's take any molecule. Let's suppose, let's take water itself, or we can take oxygen, right? So let's calculate the molar mass, right? Let's calculate the molar mass. Now we know that the mass of one atom. So let's take oxygen, right? So mass of one atom of oxygen is 16 AMU. What it is? Be very clear, be very careful about the units and what I'm talking about, whether I'm taking, whether I'm saying molar mass, whether I'm saying atomic mass, molecular mass. So you have to be very careful what am I saying or what the question says. Is it talking about molar mass? Is it talking about atomic mass or molecular mass? So you have to be very careful when you are reading the question. So here, as you know from our previous classes, that the mass of one atom of oxygen is taken as 16 AMU. Now I have to calculate the molar mass. So if the mass of one atom is 16 AMU, now in 1 mole, how many atoms I'll have? I'll have 6.023 into 10 raised to the power 3 atoms of oxygen. So mass of 6.023 into 10 raised to the power 23 atoms of oxygen will be, how much it will be? 6.023 into 10 raised to the power 23 into 16 AMU. Right? Now, this can be written as Na, right? And also, what did we learn? This AMU can be written as 1 upon Na. And here we will have grams, right? So I have converted 1 AMU to grams. So from here, what I'll get, this, the molar mass of oxygen will be 16 grams, right? The molar mass of oxygen will be 16 grams. So what is the conclusion for you? So I have shown you the process that whatever mass you have in atomic mass unit, it will be same in grams. But yes, it is very important for you to know how did we get this. So now from here, what you can say is that whatever mass that you are seeing in the periodic table is the molar mass of that particular element. That is the mass of 1 mole of a substance. So here what you will see is, what will be written is 16 gram per mole. So 1 mole has a mass of 16 grams. So what's the unit? Gram per mole. I hope this is clear to you so that we can move ahead with the question that I gave you. So from there, what we can say is, so yes, what it is asking me about what is the number of moles for the 54 grams of water, right? So you just have to simply use the unitary method that you do in maths, and then we will make a common formula for it, right? A general formula. So how do we find out the number of moles? So 18 grams is equivalent to 1 mole. So in that case, 54 grams will be equivalent to how many moles? 54 divided by 18. So how much I'll get? I'll get 3 moles. So 54 grams is equals to 3 moles of water. If this is clear to you, then we will move ahead with the next thing that it is asking about, to find out the number of particles. This is a very important topic that is going on, which you would require, just not in this chapter. It will help you in other chapters also. And this is the very basics of the numericals that you will be seeing in other units. So if this is clear, then we will move ahead. So that's how you will find out the mole. So if you remember nothing, if you even forget the formula, you know the basics that the 1 mole of water is equals to 18 grams. So whatever quantity you have to find out, you have to keep it on the right side, right? So 18 grams is equivalent to 1 mole. So 54 grams will be equals to how many moles? 54 divided by 18, and in that case, I'll get 3 moles of H2O. Now, can you find out the number of particles? So, in 1 mole, we have 6.023 into 10 raised to the power 23 molecules of water. So now, obviously, what we have to do is, so in 3 moles, how many particles we will have? 3 into 6.023 into 10 raised to the power 23 molecules of water. And the same thing we have to do for the volume. But again, I'm telling you that the volume is for gases. It is applied to gases. Don't ever forget this thing, that the volume that we are talking about is for the gases. So what is the volume? So again, the volume will be 3 into 22.4 liters. It will be 3 into 22.4 liters. So I hope this thing is clear to you. Like, how are we going from mass to moles? And then from there, we can find out what is the number of particles and what is the volume occupied. So here, we'll just relate all the things in one place. And what you have to do from here is you have to make the same thing on plain paper and keep it with you so that you can revise it again and again. So what we are trying to find is moles. And there are certain quantities that may be given to us. So this can be related to mass. That's what we did, right? So from 54, we wanted to find out what is the number of moles. It can be related to number of particles. It can be related to the number of particles. And also we have volume. What do we have? We have volume. Now, let's suppose the mass is given to me. What is given to me? The mass is given to me. Then what I have to do is I have to divide this by the molar mass. So what I have to do is I have to divide this with mm is molar mass. And in case if moles are given to me, then what I have to do? I have to multiply it with the molar mass. Just look at this thing. This is a very important thing I am telling you. Look at this thing and absorb it, and then we'll move on to the number of particles. So from here, what I can say is if I have to find the number of moles, so what I have to do is I have to divide the given mass, whatever is given to me in the question, by the molar mass, right? And similarly, if the number of moles is given to me, then I can find what is the mass of the particular given number of moles. So what I have to do is, if moles are given, then if I multiply it with the molar mass, I'll get the mass of that particular moles. And if the mass is given to me, then if I have to go to the moles, then I have to divide it with the molar mass. If this is clear, then we will move on to the number of particles. Yes, if this thing is clear, then we will move to the number of particles. Yes. Now, yes. So, if the number of particles are given to me, if the number of particles are given to me, correct? Here, number of particles were given to me, and I have to convert it to the moles. What I have to do? I have to go from number of particles to the number of moles. So again, I have to divide it with the molar mass. And for the opposite thing, that is, if I want to go from moles to the number of particles, then I have to multiply it with the molar mass. So from here, what I can write is that number of moles can be found out by dividing the number of particles by Na. So yes, I wrote molar mass. So what we have to write here? Na, right? We have to do it with the respect of Na. That is the number of, Na is the number of particles in 1 mole, right? So if number of particles are given, then I have to divide or multiply with the number of particles, that is Na. If we have to deal with the mass, then we have to multiply or divide with the molar mass. If this is clear, now we will move on to the volume. So let's suppose if the volume is given to you and you want to go to the number of moles, then in that case you have to divide it by 22.4. And if you are given the number of moles, then you have to multiply it by 22.4. So from here, what I can write is that if I am given some volume, then I have to multiply it by 22.4, and this is true for gases. This applies to only gases. So how we can find out number of moles? So this is the way I can find number of moles, and vice versa. If number of moles is given, then yes, of course, I can find the given mass, I can find the number of particles, and also I can find out the volume. And these are the things that you have to remember. And this is the overall chart that you have to keep with you and keep revising. And then you have to solve the lots and lots of problems so that you understand this well, that whenever somebody says you 1 mole, then it corresponds to 6.023 into 10 raised to the power 23 particle, and the mass of these many particles is equals to the molar mass, and the volume that is occupied by these many particles, if it is in gaseous form, then it is equals to 22.4 liter. I hope this whole thing is clear to you. So you just take 1 minute, read this everything and absorb it, and then I'll give you some more questions. So here I'll give you two more questions. Yes, if this is clear to you, you have to type yes in the chat box. And then there is one other important thing I'll tell you from this relationship. Yes, Fatima has understood. What about Gayatri, Deepika, Rakshit? Rakshit, have you understood this whole thing? If there is any doubt, you can ask it. You can stop here, because this is a very, again and again, I am telling you, this is a very important part of chemistry, which will be there in almost all the units. Especially, this will be very helpful in physical chemistry. Na, oh, okay. Na is Avogadro number, right? That's what is 1 mole, which is equals to, okay, this is Na, which is known as Avogadro's number. In his honor, this number was named as Avogadro number. And if you don't want to write it again and again, simply you can write Na. And then other things you can do after that. Yes, Rakshit, have you understood this? If you are there, you have to reply so that we can move ahead with some other things. So if this thing is clear to you, now you will get a variety of numericals based on this particular concept. Now the level of the questions will change, but the concept remains the same. If you are given a mass, if you are given a mass and you have to find the number of moles, then simply you have to divide it with the molar mass. If you are given the number of particles, then you have to divide it with the Avogadro number. So here also I'll write it so that you are not confused. So Na is 6.023 into 10 raised to the power 23. So if you divide the given number of particles with the Avogadro number, then in that case you will find out the number of moles. Similarly, if you divide the given volume with 22.4 liter, you will get the number of moles. And simply we have come with the formula based on the unitary method. If 1 mole is these many particles, then these many moles will be equals to how many particles. So it's as simple as that. Now, the more numericals you will practice, the concepts will be much clear to you. Now, the other kind of numericals, so see, there can be direct questions, which is like they may give you the mass and ask you the number of moles. Now, the indirect question will consist of, here you can see this thing, right? Here it was easy to understand. But in other cases, what they can do is they will directly give you the mass and they may ask you the number of particles. What I'm saying is, they may give you the mass and they may ask you the number of particles. So now what I have to do is look here very carefully is, I have been given the mass and I have to go from mass to the number of particles. So there is no formula like that, right? So what we have to do is, first I'll have to find out the number of moles. For that, I know the formula, that given mass divided by molar mass. And then once I have found out the moles, then I can find the number of particles. You can't directly jump from mass to number of particles. That is what I mean. Let's suppose if you are given a mass and you are asked about the number of particles, then you don't have to sit there or you don't have to be confused. Okay, I only know the formula for given mass and molar mass. How can I go from mass to number of particles? So the only way is first convert this mass to mole, and then obviously from this relationship we know that yes, we have a path in which we can go from moles to the number of particles. In the similar way, if you are given the volume and you want to find the mass for the particular volume, then same, you have to do the same. If you are given volume, go to moles and then to the mass or the number of particles. Or if you are given the number of particles, you have to find out the moles and then you can go to volume or you can go to the mass, whatever is asked to you. So the first thing that you have to do is, if they are going from mass to volume, then the first step that you have to follow is find out the number of moles. What you have to do, find out the number of moles, and then you can do whatever you want to do, whether you want to find the number of particles or whether you want to find out the volume. If this is clear, then we will move ahead. I'll give you some problems. So just quickly type here y and then we will move. So Rakshit haven't replied yet. Yes. What about others? Yes, Gayatri have understood this all. So now your homework is the first kind of questions which you, that will be the part of the other question, is the calculation. So what you have to do is calculate the molar mass. Just for the practice, you have to do this. That is, I'll be writing the molecules and then as a homework, you have to calculate the molar mass of these compounds. So calculate the molar mass. So here I am writing the compounds, which is you have to do it for sugar, you have to do it for glucose, you have to do it for urea, you have to do it for acetic acid, you have to do it for formic acid. Now I am expecting that you know what are the formulas. If you don't know, you have to find out and write the formulas, and then you have to calculate the molar mass, which is the mass of the 1 mole of substance. Similarly, you have to do it for the ionic compound, which is you have to do for aluminium sulfate, MgCl2 dot 6H2O. Also, let's take one coordinate compound. Let's see if you will be able to do this or not. K4FeCN6. And you can do it for calcium carbonate. So yes, I think these many molecules are enough. So you have to find out the molar mass for these molecules. And the very important thing for you here is that you should know what's the difference between sugar and glucose. And here is where the confusion comes. Whenever you are given any numerical, you will find these kind of numericals in your book also, where sometimes they'll give you glucose, sometimes they'll give you sugar. And both of these compounds are different. So you have to pay attention to that. Now, this is the first problem. And the next problem is you have to calculate the mass of 1 mole of electrons. I think you can do this, right? We know what is the mass of 1 electron. So if you know the mass of 1 electron, I hope you can calculate the mass of 1 mole of electron. Now let's take one more question, previous year question of JEE. So in that you have to calculate, what you have to do is you have to calculate the number of moles of electron which will give, or we can say which will be equals to 1 kg. So you have to calculate number of electron that will be equals to 1 kg. Number of moles of electrons, that will be equal to, you can write it as equal to 1 kg, or gives 1 kg. Gives is also fine, equals to 1 kg is also fine. So I hope you have understood this problem. So these are the three questions that you have to do based on this particular relationship, which is very important for you. So just take a plain sheet, write this down and keep it with you along with the periodic table. So for today, what you can do is go there and see the molar masses of the common elements which you are using or which you see every day in our session. So at least you must memorize the molar mass of those elements. For example, you should know it for magnesium, sodium, aluminium, copper, chlorine, bromine, not iodine, yes, chlorine, bromine, fluorine, calcium. For all those, yes, it is expected that you should know the molar mass of these elements. So today, go there, learn the molar masses and solve these problems. And we'll see many more problems related to the mole concept, which I'll bring in the next session. Now, after this, what we have to learn? We will be learning about the stoichiometry. So this is all for today. So try to solve these problems and I hope you will be able to do this. So with this, you can continue with the next class. So ma'am,
Yes, ma'am. Yes, ma'am.
yes.
Yes,
So
thank
I
you,
have
madam.
given, yes, I have given some problems. So you can check with the students. Okay, then see
Okay,
you
ma'am.
all in the next class.
Now I would like to invite Arun sir to continue the session.
Thank you, ma'am.
Thank you, sir.
Right. Yeah. Hello, students. How are you all? So let's get started. Let's continue with the session. So I give you some problems as homework. Hope you have all tried. Hi. Good evening, Gayatri. Good evening, Jyoti. Hi, everyone. All right. So we were doing transformations yesterday. We dealt with f of x plus a, which is upward, a greater than 0, f of x minus a, downwards, f of x plus a, leftwards, f of x minus a, rightward, f of minus f of x is reflection with respect to x-axis, f of minus x, reflection with respect to y-axis. Yeah, hello, Manaswini. Good evening. Yeah, so these are the things we dealt with yesterday, till yesterday. So we'll continue with the class. I'll give you certain functions. Let's quickly plot it within a minute. And the minute starts now. X minus 2 whole square plus 2. Does it have roots? Does this equation have roots? Quick, yes or no? X minus 2 whole square plus 2. Does this equation have roots? Uh-huh. How do you find out root, whether it has roots or not? I'll quickly sketch this equation. If this intersects with x-axis, it has roots, otherwise it doesn't have roots. Okay, Bhavna is correct, Gayatri is correct. Let's see. Hi Fatima. This is x square X minus 2 would be translating it towards right, this one. So I'll get x minus 2 whole square, plus 2 would be translating it upward. So this is 2, this is 2. So this is 2 comma 2. So it doesn't intersect with x-axis, so no roots. Right? Now let's say if I've got minus of x square, x minus 2 whole square plus 2, then what do I do? Does this have roots? Quick. Quick, 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 quick. Quickly do it in your mind's eye and tell me, does this have roots? Yes, Gayatri says yes, Bhavna says yes. Ifra, what's your answer? Manaswini, Jyoti, please answer. Good, good, Jyoti. Good, Ifra. Good, Gayatri, excellent. It has two roots. All right, good. All right, now let's plot this one. Y is equal to 2 minus x whole square. How do I plot this? Y is equal to 2 minus x whole square. So which one would I use? I would use this one as well. I would use two transformations now. One is this one, x plus a, and then f of minus x. This is x square. I'll first do x square, then x plus 2 whole square, or 2 plus x whole square, which is nothing but this one. 1, 2, 3, 4, 5, and 6. So third one is 2 plus x whole square. Translating it towards left with 2 units by 2 units, I'll get this one. Now I'll substitute f of minus x, which is a reflection about y-axis. So I'll get this. So this is my answer, 2 minus x whole square. All right. So whenever you have minus of x, do it at the end. You first transform all the other transformations, then you substitute f of minus x, which is reflection about y-axis. All right. So I first have x square, x plus 2 whole square is shifting it towards left. This way, third one.
Sir, your voice is not audible.
Yeah. Madam, are you able to hear me? Am I
Yes.
audible?
Yes, now it's clear, sir. Now it's clear.
Excuse me, ma'am.
Yes, sir, now it's clear.
Ma'am, am I audible?
Yes, yes. Yes, sir, you're audible.
All right. Students able to hear me?
Yes.
All right. Good. So now let's move on to the next one. Let's go for trig functions. Same transformations for trigonometric functions. Say I've got sine function as, which is like this, and it goes on forever this way. But this is my sine function basically between 0 to 2 pi. This is pi, this is 2 pi, this is pi by 2, this is 3 pi by 2. All right. So this is my sine function. Y is equal to sine x. Now, how is cos x? What did I tell you? Both are exactly the same in structure, identical in structure. Only the thing is the difference is shifted. One is shifted. Do you want to speak, Bhavna? Do you want to speak? Do you want to unmute yourself and speak? All right. Let's continue. Now look at this. I've got a cos function like this, where this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, and this is 0. Now look at this. If I shift this sign towards left by pi by 2, I'll get cos. How do I shift towards left by pi by 2? Third one. So I'll have sine of x plus pi by 2 is cos x. This we already know. But from graph, it is more evident. We already know this from the structure, from the circular symmetry, circular functions. We already know this. We also know this from memory as well. That's good. But this is more evident from the graph. So if I remember these two graphs, I can quickly tell these transformations. How can I get sin x from cos x? I can write cos of, I should shift this cos graph towards right by pi by 2. So cos of x minus pi by 2 is equal to sin x. Is this clear, students? These transformations are very much evident from the graph. So it is even more easier to, for us to quickly conclude about the transformations through graphs. Even if you're slow in circular circular functions from the circular geometry, we can do it faster than from the graphs. If I know sine curve looks like this and cos looks like this, one is a shift of the other by pi by 2. So sine of x plus pi by 2, which is shifting the sign towards left by pi by 2, is cos. Shifting the cos towards right by pi by 2 is sine. Now let us shift some more functions. Let's see what happens if I shift sine of x minus pi by 2. What do I get? From the graph, can you tell me? What do you get x minus pi by 2? X minus pi by 2 is nothing but this function is being shifted towards right by pi by 2. So this is what I get, which is nothing but minus of cos. See, minus f of x is reflection with x-axis. So what I get is minus cos like this. So these transformations are very easy for us to conclude from the graphs. If we know just two graphs, we are done. Sine and cos ఎలా కనిపిస్తే మనకు తెలిస్తే మనం అన్ని transformations quickly చెప్పొచ్చు. All right. For instance, now let us see how does minus sign look like. Now, what is this minus of sign? That means I'm reflecting the sign with respect to x-axis. So I get this. దీన్ని రిఫ్లెక్ట్ చేశాను. దీన్ని రిఫ్లెక్ట్ చేస్తే ఇది వచ్చింది నాకు. Now let us see how do I get this from this. So minus cos of x minus pi by 2 is nothing but minus sin x. Very evident from this. These two are identical. See, just minus gets cancelled out, I get the same thing. But I got its transformation from the graph. All right. If కనిపిస్తుంది అది మీకు? Are you able to see? Is it clear? Is the transformation clear, students? We'll quickly go for cot, tan and cot. Okay, now tell me one thing, students. నేను ఒక ఫంక్షన్ డ్రా చేస్తాను. That you have to get it from sine and cos, from both sine and cos. We can get, see, any sinusoid, I can get it from both sine and cos, right? Now this is my this thing. Now this is phi. This is a sinusoid. Now this sinusoid, I want to get this transformation from sine function. So how do I get it? I should push this sine towards left by phi. So that would be sine of x plus phi is my this sinusoid. So equation of this is this. But how do I get this from cos? I can do these transformations over here. I know sine of x plus phi to x minus phi to all these transformations I know, but it is even more easier to do with graphs. That's why I'm telling you graphs. Now look at this cos. Cos looks like this. Now this is to be shifted towards right by how much? This should be phi. So this should be shifted by pi by 2 minus phi. So I'll have y is equal to cos of x minus pi by 2 minus phi. Now cos graph icharu. From cos graph, how do you get this graph? By shifting it by pi by 2 minus phi. ఎందుకంటే ఇది phi ఉంది. Okay, phi phi. phi. Is it clear, students? From sine, I had to shift it towards left for sine. To get the sinusoid from sine function, I had to shift sine towards left by phi. But cos, I had to shift it towards right by pi by 2 minus phi. So shifting it towards right is x minus a. Look at this fourth one. And what is how much do I have to shift? By pi by 2 minus phi, not phi. Phi is where I have to ultimately come to. But I should shift it by pi by 2 minus phi. Is it clear? Quickly say yes or no. We got to go to the next concept. Type clear in the chat box if it's clear. All right, good. Only 3 or 4 members are answering. Okay, now look at one more transformation, one more quadratic transformation. We'll come back to that at the end. But right now, let's start with differentiation or limits. Limits and differentiation. Oh, let's do tan first. Tan cot chasesi. Then let's go for limits and differentiation. This is my tan function, right? And so on. It goes on forever. This period, this is repeated forever. So this is my minus pi by 2 plus pi by 2. This is y is equal to tan x. Now, how is y is equal to cot x? Cot x looks like this. Zero, pi, 2 pi, at pi by 2. This is cot. Now I want to get this cot from tan. How do I get it? Transformation Rasamu, but from graph, let us see how do I get it. I'll first shift it towards left by pi by 2. All right. నేను left కి షిఫ్ట్ చేస్తే ఏమొస్తుంది నాకు? I'll get this graph. Now let's focus only on the one segment of the infinite graph. Left కి షిఫ్ట్ చేస్తే ఇలా వస్తుంది. Right? Now దీన్ని నేను రివర్స్ చేయాలి. అప్పుడు నాకు cot వస్తుంది. So this is minus cot. సో లెఫ్ట్ కి షిఫ్ట్ చేయడం అంటే ఎలా చేయాలి? tan of x plus pi by 2, which is minus cot x. This we know from transformations. Graph nunchi inka easy undi idi. Look at this. Tan of x plus pi by 2 is shifting it towards left by pi by 2 and reversing it, which is nothing but minus cot x. Is this clear? I'm going a little faster, students. We got to cover a lot. All right. Once we enter into physics, we'll enjoy physics. I guarantee that. But this is also very important. So I have to strike a balance between going faster and going slower. All right. Yes. Okay. All right. So I get tan of x plus pi by 2 is minus cot x. Now, what is tan of x? I erase this red part. Now I'll write a transformation. From the graph, you tell me what do you get? Tan of x minus pi by 2 is equal to what? Tan of x minus pi by 2 is what? So x minus pi by 2 ante, this is shifted towards right by pi by 2. I get this. X minus pi by 2, students. X minus pi by 2. మైనస్ కాటే వస్తుంది చూడండి. What is tan of x minus pi by 2? Yeah, sure, Ifra. That's okay. Sure. I'll take care. That's okay. Yeah. Thanks for informing. That's good you informed. All right. Okay. So tan of x plus pi by 2 is minus cot x. Have you understood this, Ifra? This one, have you understood? How did I get tan and cot transformations from the graph? Have you understood that, Ifra? Okay, good. Now let's go for tan of x minus pi by 2. What is tan of x minus pi by 2? I shift the graph towards right because x minus pi by 2 hai na? So I shift the graph towards right by pi by 2. So I get this red line, red curve. Now what is this red curve? It is inverse of this one, see? Now look at this. This is nothing but inverse of this one. What inverse? Reflection along about x-axis. See, if I reflect this, I'm getting this. Or if I reflect this, I'm getting this red line. So this is cot, this is minus cot. So tan of x minus pi by 2 is nothing but minus cot x. Pretty simple, right? So if you just remember 4 graphs, you're done. What are the 4 graphs? Sine, cos, tan, and cot. All right. Secant, cosecant we don't use. We use very rarely, but sine and cos we use heavily. All right. So any transformation, if you remember these 4 graphs, you're done with it. All right. Now let's see one more thing. That's it. So is this clear, students? All right, Bhavna. I'll inform that. All right, we'll do something about it. All right, is this clear, students? Tan of x minus pi by 2 is equal to minus cot x. Is this clear? Everyone? Okay. Jyoti says yes. Okay, Gayatri says yes, sir. Ifra, is it clear? Bhavana, is it clear? Rakshit, is it clear? Are you there? Are you listening to the class? All right. So Rakshit, are you there? Okay. Anyways, seems like Rakshit is not responding. All right. Now let's move on to one more interesting point which we are going to use in now. This is my tan function. This is my y is equal to x line, and y is equal to sin x would be like this. So sin x, x and tan x are in a graph, they look like this. What I mean by look like this is the y is equal to x line is sandwiched between tan x and sin x. All right. Y is equal to x line is sandwiched. All right. This is called squeeze play theorem. Squeeze play. This is being x is being squeezed between tan x and sin x. Look at this. Tan x is coming from above, and this is my y is equal to x line, and sin x is sandwiching it from below. So x is being sandwiched between tan x and sin x. All right. Now, if you can, so from this graph, I can write sin x is less than x is less than tan x when x is tending to 0. When x is very close to 0, this is my inequality. We can prove this inequality, but we'll not prove it right now. We'll see if I have at the end of the class, if I have time for 5 minutes, I'll prove it. All right. The proof is interesting and also useful in next year as well. There are many problems on that proof, many good problems. In previous year papers, there is a problem on that proof itself. So this inequality is what you have to remember. So as x tends to 0, sin x is less than x is less than tan x. So sin x tends to x and tan x tends to x as x tends to 0. So I can approximate sin x by x. Sin x is approximated by x. Tan x is approximated by x when x tends to 0. Only when x tends to 0, I can replace sin x by x, tan x by x with an approximation. That's an approximation. Okay. So you will have some error creeping in, but that's an approximate value. Sin x is sin x a value actually. But because x is being sandwiched between tan x and sin x, x is always between sin x and tan x. So as x tends to 0, sin x tends to x and tan x tends to x from upper side and lower side. ఇది కింద నుంచి x towards x వస్తుంది, ఇది పై నుంచి towards x వస్తుంది. tan x పై నుంచి వస్తుంది, sin x కింద నుంచి వస్తుంది. Alright, చూడండి గ్రాఫ్ లో చూడండి. Alright, so remember this one, that x is being sandwiched between sin x and tan x. Alright, now let's go to proof. We'll see at the end of the class. All right, now let's understand one thing. We were doing functions, a bit of functions, a bit of transformations, reflection, translating it, reflecting it about x-axis, about y-axis. You've done all these transformations. There are two more. We'll talk about it later. Okay, let's get the intuitive understanding of each and everything. But right now, okay, those two more you can write it right now itself. You just note it down. One is kf of x. Second is f of kx. One more is f of mod x. Other one is f mod f of x. Seven, 8, 9 is f of mod x. Next one is mod f of x. All right. These we'll deal with it later. All right. Once I teach you what is mod x, then how to deal with mod x. Mod x is also a very important function for physics. then we'll understand how to deal with these transformations. Okay. All right. Calculus, there are two aspects to it: differential and integral. We'll get a glimpse of both in the next 10 minutes. All right, we'll see what are both in next 10 minutes. Just a glimpse of it. We are not going to do the way it is done in mathematics class. We are going to do it the way it is used in physics class. All right. So we are not doing mathematics here. We are doing mathematical physics here, to be more specific. All right. Now, let's talk about differential calculus, in which I have got a curve like this. All right. Some curve like this. I'll erase this. This is done. Now, this is y, which is f of x, and this is x. I've got at x, I've got some function value which is f of x. Let that be y1. This is x1. At x2, which is x plus delta x, I've got another point which is having a value of y2. What's the value of y2? F of x plus delta x, right? So how much is this distance? This distance is delta x. This distance is delta y. Students, I'll go slow. That's okay. This is a very important concept. We'll straight away enter into kinematics a bit. Right after this, we'll straight away enter into kinematics and come out. All right. So let's go slow, but go strong. So I've got delta y and delta x. So this vertical distance is delta y. Horizontal distance is delta x. So distance between 2 points is delta x on the horizontal x-axis. On the vertical y-axis, distance between these 2 points is delta y. All right. So what is delta y? F of x plus delta x minus f of x is delta y. All right. So what if I do delta y by delta x, what do I get? Delta y by delta x, what does it give me? If I join this chord, this is called a chord, right? For a circle, this is called a chord, no? Like that. For any curve, a line joining these two, intersecting this curve at 2 points is called a chord. Chord is not specific only for a circle. For any curve, it is called a chord. C-H-O-R-D. C-H-O-R-D. Chord. All right. Now, the slope of that chord is how much? What is the slope of that chord? Delta y by delta x. All right. Now what I do, interestingly, which is very important for both mechanics, geometry, and calculus, mathematics. So, but we are more interested in mechanical and geometrical interpretation of this concept. This concept actually comes under differential calculus, but this has got applications in mechanics and geometry. We are interested in both geometrical and mechanical applications of this concept. So I'll be dealing with this concept pertaining to those applications. ఆ అప్లికేషన్స్ కి యూజ్ అయినట్టు నేను ఈ కాన్సెప్ట్ ని టీచ్ చేస్తాను. ఆల్రైట్, we are not bothered about deep mathematics of it. Alright, we are going deeper than that, but applied to physics. So I've got this chord. This coordinate slope of the chord is this much, delta y by delta x. Now what I do, I'd go on decreasing this delta x. Delta x ని డిక్రీజ్ చేస్తా. ఇప్పుడు chord ఎక్కడి వరకు వస్తుంది? chord ఇలా వస్తుంది. ఇంకా డెల్టా ఎక్స్ డిక్రీజ్ చేస్తా, అప్పుడు chord ఇలా అయిపోతుంది. ఇంకా డెల్టా ఎక్స్ డిక్రీజ్ చేస్తా, chord ఇలా అయిపోతుంది. Finally, when I do delta x closer and closer to x, that means if I say limit delta x tends to 0, delta y by delta x, which is the slope of the chord, what I get is slope of the tangent. So slope of the tangent is nothing but limit delta x tends to 0, delta y by delta x. This makes sense because this chord is becoming a tangent when delta x tends to 0. All right, delta x is tending to 0, then this this chord is becoming a tangent. See, this chord black line is slowly turning into red line, red line, red line like this, red line, and finally becoming a tangent when delta x tends to 0. That time, the chord of this curve becomes tangent to the curve. This chord became the tangent. So the slope of the chord then turns into slope of the tangent as delta x tends to 0. This slope of the tangent is represented by this, which is read as not dy by dx, it is read as dy dx. dy dx. All right, it is not by there. There's no by, but here we say by delta y by delta x. So that's okay. Sometimes some people say dy by dx. That's okay, but it is more technically called dy dx is equal to limit delta x tends to 0, delta y by delta x. So this chord, slope of the chord, is now a slope of the tangent when delta x tends to 0. Is this clear, students? Is this geometry clear? Is this notation clear? This is just a notation. This is not mathematics. It's just a notation. Slope of the chord when delta x tends to 0 becomes slope of the tangent. Please type clear in the chat box or yes in the chat box. All right, Jyoti says cleared. Others, please respond. Ifra, Bhavna, Gayatri. Who else is there? Manaswini. Okay. All right. Understood. All right, Manaswini says understood. Good. All right, now let us do one thing. Let us start analyzing a case which you already know from your 9th standard. All right, even if you don't know, you'll understand it. Don't worry. So I'm erasing it. So dy dx is equal to limit delta x tends to 0, delta y by delta x is the slope of the tangent to the curve f of x, or y is equal to f of x. And that's also read as derivative of y with respect to x. All right. Okay. Now I'll go really slow. All right, we have got 10 more minutes. I'll go slow, but I want to complete this one. I've got a ball, small ball, particle, which is being released from certain height. All right, certain height on ground under gravity. So what happens? How do I write the displacement of this? S is equal to half gt square is the displacement of the particle after a certain time t. Right? And what is the velocity of the particle? V is equal to gt. These all things you know. I know S is equal to half gt square. I know V is equal to gt. And the acceleration is g. These all these things you know, right? Type yes in the chat box if you know this. From V is equal to u plus at, I got V is equal to gt because u is equal to 0. I released it from rest. And S is equal to ut plus half at square. U is 0. So ut becomes 0 plus half at square, where a is g, half t square, half gt square. Downward I have taken as positive. All right, convention is downward as positive. That's why I got plus half gt square plus gt and plus g. All right, good. Now I'll plot this curve. Y is equal to half gt square. How do I plot that curve? That's the standard quadratic. All right, I know x square, kx square would be nothing but stretching it k times. Let's say I've got number 2. If I multiply it by 2, it goes to 4. That means I'm stretching this 2 by 2 units. So similarly, if I've got x square, kx square would be stretching it by k units. So x square I know, parent function, which I stretched it by g by 2 units or 5 units. Let's say if I take g as 10, I multiply it by 5. So 5 units I've stretched it. Stretching later. That's okay. You don't have to bother about stretching. So this is my s equal to ut plus half t square, which is s equal to half gt square. Now what I do, this is, sorry, s. This is t, this is origin, this is negative t. All right. Now my question is, one question is negative time possible? Can time be negative? From your knowledge of 9th class, can time be negative? Bati says no. Bhavana says yes, time can be negative. Can time be negative, students? Quickly answer, I'll just give you 10 more seconds. Can time be negative? Jyoti says no. All right, good. Time can be negative. Negative time has got a significance. Yes, Bhavana, that's absolutely right. That's absolutely right. We'll come to that. Time can be negative, students. Delta t cannot be negative. Time interval cannot be negative, but time can be negative. Delta t cannot be negative, but t can be negative. T can be negative, it has got physical significance, which is deals with past. T positive deals with future. T equal to 0 deals with present. T negative deals with past. All right, we'll come to that. But right now, let's erase this part. Negative time, let's erase it. We don't have to bother about this negative time. Let's talk about negative time when we deal with negative time. Now I've got a function like this, which is half gt square. I take at certain time t, I draw a chord like this. At time t. At another time t plus delta t, this chord intersects the curve at t plus delta t. So this distance is delta t. So this distance is how much? Delta s. All right, this distance is, Bhavana, this is absolutely right. I appreciate your knowledge. Good. All right. Now, delta s is this, delta t is this. So what is the slope of the chord? Delta s by delta t. So how much is delta s now? What is delta s? It's half g t plus delta t whole square, half g t plus delta t whole square minus half g t square, y2 minus y1 by x2 minus x1 is this is my delta s by delta t. Is this okay? Is this clear, students? This is the slope of the chord. This is the slope of the chord, right? Y2 minus y1 by x2 minus x1. X2 minus x1 is delta t. Delta s by delta t. Delta s is this much. Y2 minus y1. Half g t plus delta t square minus half gt square by delta t is my delta s by delta t. Now what I do, I apply limit. Delta t tends to 0. Now let's see what I get. So I expand this, half gt square gets cancelled out, half gt square plus half g delta t square plus g delta t minus half g t square by delta t. So half gt square gets cancelled out, minus half gt square minus half gt square gets cancelled out. What remains is this. Gt delta t over here. I just expanded this, a plus b whole square. All right, nothing new. I just did a plus b whole square, a square plus 2ab plus b square, a square plus b square plus 2ab. That 2 and 2 got cancelled. Gt delta t. All right, just to skip a step, skip space, save space, I've done it. So this becomes now delta t also gets cancelled out. So what I get is, because delta t tends to 0, it is not equal to 0, so I can cancel out. It is not of the form 0 by 0. It is non-zero. Delta t is non-zero. It's tending to 0. So I can cancel it out. So I'll get gt delta t plus half g delta t. And this is limit delta t tends to 0, delta s by delta t. Now to substitute delta t tends to 0. What is delta t tends to 0 now? This becomes 0. What I get is gt. Students, I started with position. I got velocity. And what is this I told you? This is nothing but derivative of s with respect to t, ds dt. Because limit delta t tends to 0, delta s by delta t is nothing but ds dt. ds dt is what? Derivative of s with respect to t. If I differentiate s with respect to t, I am getting velocity. All right. So I can say that velocity is nothing but derivative of s with respect to t, derivative of displacement with respect to time. Is this clear? Do you agree with all this? All that I've done? I repeat. I took the curve s equal to half gt square. I took delta s by delta t, which is delta s by delta t. Delta s is nothing but half gt plus t whole square, y2 minus y1 by x2 minus x1. So y2 minus y1 is y2 is at t plus delta t, half g t plus delta t whole square. Y1 is half gt square at t. I expand this a plus b whole square, a square plus b square plus 2ab. I cancel half gt square and minus half gt square. After that, because delta t tends to 0, I cancel out delta t as well. Delta t square నుంచి ఒక delta t వెళ్ళిపోయింది, ఈ delta t వెళ్ళిపోయింది, delta t వెళ్ళిపోయింది, cancel అయిపోయింది. All right. Now what remains is I substitute delta t tends to 0. As this tends to 0, this becomes 0. What remains is gt. That means tangent, slope of the tangent of st curve is velocity. That's what I can conclude. And derivative of s with respect to t is velocity. Is this clear, students? Till now, is it clear? There's just a manipulation of equations, that's it. But there was a interpretation to it. And what's the interpretation? That derivative of s with respect to t resulted in velocity. So v is equal to ds by dt. Is this clear? All right, Jyoti says yes. Others, please quickly tell me. I'll just give you 10 more seconds, then I'll move on. If it's not clear, please let me know now itself. You can unmute yourself and speak. Otherwise, we've got last minute. Students, okay, I'm just getting a couple of responses. If you don't respond, I'll presume you have understood. I'll go ahead. Okay, Vaji says yes. Please respond, students. It's the online Gada, so it will be difficult if I don't respond. If you don't interact, it will be difficult for me. Otherwise, then it seems as if I'm speaking to the wall. All right, please respond. Class goes quicker if you respond quicker. If your response is quick, class will go quickly. All right, good. All right, Bhavna has got it out. All right, so Bhavna, you should not wait so much for me to ask you that if you have a doubt. If you have a doubt, please raise the doubt. All right, so where's your doubt? You want me to repeat this? Okay, it's clear. All right, good. All right. No, don't hesitate, Bhavna. All right, please don't hesitate. No one. See, you all are here to learn, and I'm here to teach you. So please don't hesitate to ask anything, any damn thing. All right. Now, let's do one thing. We know V is equal to GT and A is equal to G. So what will you conclude? Slope of the graph of ST curve at this is velocity. That is what V is equal to ds dt. I'll erase this. Hope you have taken a snapshot of this one. Very important. All right. Now, so I've got a ST curve, half g t square, slope at point t gave me velocity, which is V is equal to gt, like this. A straight line passing through origin, y is equal to mx now. The straight line passing through origin is V. If I further differentiate this, if I find out delta V by delta t, what do we get delta V by delta t? G. What is the slope of this line? Slope of ET curve? G, right? So what do we get now? I get a constant line G. So acceleration and time t. So look at this. Slope of ST curve gave me V. Slope of VT curve gave me A. That means information about the velocity and acceleration is hidden in ST curve. In displacement itself, I have my velocity and acceleration embedded in it. ఆ ఇన్ఫర్మేషన్ దాంట్లో ఉంది. నేను ఎలా తీయగలను? Using differentiation. So if I differentiate s with respect to t, I get velocity with respect to time. If I differentiate velocity with respect to time, I'll get acceleration with respect to time. So rightward, my information is encoded or decoded using derivatives. d dt. I differentiate this with respect to time, I get this. I differentiate this with respect to time, I get this. But now, if at all I want this information from here, can I get it? This information from here, or this information from here, because all these are graphs about the same motion. All graphs will have same motion encoded in it. All we have to do is decode using differential or integral calculus. Look at the students. At a distance of, let's say at a point t comma 0, this is t. ఇది ఎంత ఉంటుంది? gt. So what is the area of the triangle? Let's just talk of area. Let's see what we are getting. Area of triangle ఎంత ఉంటుంది? Half gt into t. Half into base into height. So half gt square. What is this? It is nothing but displacement. ఇక్కడ ఏరియా చూద్దాము. At a distance t of base t, height ఎంత ఉంటుంది? g. ఈ ఏరియా ఎంత ఉంటుంది? Base into height. gt, area of the rectangle. What is gt? gt is nothing but velocity. So if I find out slopes of this graph, I'm going towards right, from displacement to velocity to acceleration. But if I find out area of acceleration, I'm getting velocity. If I'm finding out area of VT graph under VT graph, I'm getting displacement. This process of finding out areas and getting the information of the motion, we use integration. To get the information of velocity and acceleration from displacement, we use differentiation. All right. I just told you that దీంట్లో కూడా ఇన్ఫర్మేషన్ ఉంటుంది, దీంట్లో కూడా ఇన్ఫర్మేషన్ ఉంటుంది. All that we have to do is extract the information using a mathematical tool. The mathematical tool which you're using to extract the information of the motion from the graph is calculus. The tool which you're using is calculus. If I want to extract velocity and acceleration from displacement, I use differential calculus. Differentiation. Slopes can I find out just one. Slope of ST graph is V. Slope of VT graph is A. Slope of AT graph kuda untedu untundi. We'll talk about it later. area under this graph is also something, slope of this graph is also something. All those things we'll talk later, but right now just focus on these three things: displacement, velocity, and acceleration. అదే నేను టువర్డ్స్ లెఫ్ట్ రావాలనుకోండి, నాకు 80 గ్రాఫ్ ఇచ్చారు క్వశ్చన్ లో, నాకు డిస్ప్లేస్మెంట్ కావాలి. Yeah, see, I didn't teach you what is integration. I'm just telling you that the process of getting the information from AT graph about V and S, we use integration. All right, differentiation is finding out slopes. Integration is all about areas. All right, that's the basic difference between these two. All right, we don't say difference, we don't compare both. Both are two different things. All right, and also you will also deal integration and differentiation in mathematics as well, so you don't have to worry about it. But I'm doing it pertaining to that required in physics. All right. All right, that's it for today. But I just want to repeat for 1 minute. If sir gives me permission for a minute, I'll just take a minute and just repeat. If I find out the slope of ST graph, or slope of VT graph, or slope of a graph, slope of some random graph, I talk of differentiation. All right, I go in this direction. I go from V, I get V from S, A from V. But if I want V and S from A and V, I talk of areas, which is integration. All right, in physics, we'll talk of integration as mostly as area under the graphs. So slopes of the graphs and area under the graph is what we focus on. Integration is even more wider concept than this, but we apply it with this as a, we confine it to this, that slopes మాట్లాడితే నాకు velocity and acceleration వస్తుంది, areas మాట్లాడితే velocity and displacement వస్తుంది acceleration నుంచి. But the information of the motion is embedded in all these three graphs. నాకు ఒక గ్రాఫ్ ఇచ్చినా నాకు మొత్తం ఇన్ఫర్మేషన్ నేను ఎక్స్ట్రాక్ట్ చేయగలుగుతాను. I'll be able to extract the whole of the information of the motion given any of these graphs. But how do I do it? Using differentiation and integration. All right, we'll continue tomorrow. Thank you so much for joining. I request Madam Chandrika ma'am, thank you ma'am. I'm sorry I've taken encroached into the sir's time.
Thank you, sir. Now I would like to invite Govinda sir to continue the session.
Excuse me, sir. Gurvinder sir, good evening.
Hello, hello. Good evening, sir. Am I audible?
Yes, sir, you're audible, sir.
Hi, hi. Good evening, everyone. Hi, Gayatri, Jyoti. Hello, hello, everyone. Hello. I hope I am audible.
Yes, sir, you're audible.
Okay.
Yes, sir.
So yeah, yesterday we were discussing about the derivatives part. We had completed the whole lot of it, and yeah, I am glad I have got the homework also from Gayatri, I guess. From Gayatri, right? Gayatri, are you there in today's meeting? Yes, she's there. Hello. Okay. So yeah, your homework, I have received it. Everything is correct. Just I want to know one thing from you. Yeah, yesterday I was teaching that y is equal to some function of x. I had written its derivative as dy by dx, that we are differentiating y with respect to x. Okay. I was teaching this. I just have one question from you. How did that x change to t? Like, why in all your questions you have written your answers in this form. Yesterday we did not even start talking about t. So how did that t come over there? I was curious to know uh, about why your answers were written in such format. Like, did you copy it from somewhere, or do you were doing it from some other reference book? Are you there? Okay, okay, okay. I get it.
Students, you can unmute and speak.
Okay, yes. I guess you have the access to unmute and speak. Okay, so yesterday we had discussed about the derivatives of most of the important functions. So first of all, I had taught you that y is equal to x raised to n. So its derivative would be nx raised to the power n minus 1. Similarly, if y is a constant, then it would be 0. Uh, if y can be written as a sum of two functions, let us say y1 and y2. So dy by dx would be dy1 by dx plus dy2 by dx. Okay. I was just curious about how t came. Acha, okay. So you must have got it from physics, maybe. I'm not sure. And if y is equal to some constant multiplied by another function, or let me write that other function. Okay, as y1. So it will be dy by dx equals to uh, constant multiplied by dy1 by d of x. Okay. So this was all about the yesterday, and yesterday I had given you some problems. I hope all of you have solved it because I had received just from Gayatri only. Like ma'am had given me that. So I'm not sure if others have done it. Have you completed it? Has everyone completed it? Bhavna, Omkar, Rakshit, Jyoti, Manaswini. Has everyone completed it? Okay, so you are not speaking anything. I'll just assume you have. Okay. So today we are going to be discussing about uh, we'll be moving further into derivatives, and I'll be continuing with derivatives of trigonometric functions also. Okay. See, the ones who are studying for NEET, I have to tell them one thing I forgot to tell yesterday. I was confused a bit. You don't have to remember the first principle of derivative. You don't have to remember that method I had taught you. This one. This was the method of first principle of derivative. It is a must for JE aspirants because it is a part of mathematics, but the NEET aspirants need not learn it. Okay, this is not a part of your syllabus. Actually, I was confused yesterday if it is or it is not. So I'm telling you today. You don't need. Okay. So see, the thing that I'll be teaching today, it is a part of mathematics and its derivation, like the one like how it is being derived or how it is being differentiated, how the derivatives come. It will be taught to you in a later chapter by the name of trigonometry. But since you will be using these functions in physics everywhere, so what we are doing is we are first writing the derivatives. You will be learning them and revising them for now on. अभी के लिए आपको सिर्फ याद करने की जरूरत है कि इनका डेरिवेटिव्स क्या होता है, बिकॉज यू विल नीड टू यूज देम करंटली इन फिजिक्स. बट ये कैसे डिराइव होता है, ये डिफरेंशिएशन कैसे करते हैं, दैट यू विल लर्न इन द ट्रिग्नोमेट्री चैप्टर. And the ones who are preparing for NEET, you have no option because you won't be learning how they are derived. You will have to remember it only. Okay. So first we are discussing about y is equal to sine x. So if y is equal to sine x, its derivative is cos x. Second, if y is equal to cos x, then its derivative is minus of sine x. Okay. Okay. Third, if y is equal to tan x, so its derivative is secant square x. Fourth, if y is equal to secant x, its derivative is secant x into tan x. Okay. Fourth, if y is equal to cosecant x, cosec x, so its derivative is minus cosec x multiplied by cot x. Fifth, see, I am telling you guys one thing. In case अगर अभी ये चीज याद ना हो रही, if you have any problem in remembering these, you don't have to worry because slowly you will be using these in physics and everywhere, so you will remember it slowly. Okay, so no need to take load कि यार अभी याद नहीं हो रहा, इतने सारे हैं. Yeah, I have so many formulae to remember. I don't have. Okay, so no need to get troubled for that. If it is cot x, it will be minus cosecant squared x. Okay. Okay. 6, right? We just have 6 trigonometric functions. Do we have anything else also? Why is not anyone speaking today? You can speak it. Okay. So I'll assume if you are not speaking, I'll assume that you have understood it. See, these things for the JEE aspirants, I will teach you when I will teach trigonometry. Okay. When we will learn trigonometry in class 11th, it is fourth or fifth chapter, I guess. So I don't. Okay. So during that time we will learn it. So no need to worry about how these are being derived. You can just remember it right now. Okay, great, great, good to hear that. Okay, okay, great. So these are the derivatives of trigonometric functions. You have already learned how to take the derivative of polynomial functions. Okay, okay. So moving ahead, I'll teach you some basic things. Like first we have multiplication rule. Okay. So what is multiplication rule? Let us assume our function, or I will write it as y only. Till now you have learned it as y. Our function y is being written as a multiplication of two functions. Okay. So how will you take its derivative? What will be dy by dx? Okay. So it will be first function multiplied by derivative of second plus second function multiplied by derivative of first. Okay. So just a small problem over here. I have given you y is equal to x into sine x, x multiplied by sine x. Okay. So it's dy by dx will be. Achha, first of all, I want to know, is this black mode okay for you? Like, do you have any problem with me writing on this black colored, like, is it clearly visible, na? There is no issue in color. There should not be any issue in color. Is this fine, na? Like these, or everything I am writing, it is visible, na?
Yes, sir.
Okay, okay, great. Why were you not speaking earlier? Okay, anyways. So see, I have x. What is the derivative of x? Tell me. Yesterday we had studied it. Okay. What is the derivative of x? See, it is x, so it means it is x raised to power 1. So x raised to n, it turns out to be n x raised to the power n minus 1. So n is 1, so it will be 1 x raised to the power 0. So x raised to the power 0 is 1. So it is 1. Okay.
Yes.
Yes. Gayatri, you can speak, I guess. It would be faster if you speak. See, message also is visible to me. It is not like that, but it will be faster if you speak. Okay. And sin x, I have taught you just now only. It is cos x. So it will be y1. Y1 as it is derivative of second thing. That is cos x plus y2. Y2 matlab sin x as it is multiplied by first ka derivative. That is 1. So it is x cos x plus sin x. Okay. Fine. Okay. So now we will do it for uh, x square cos x. Okay, tell me what will be the answer for x square cos x? Tell me. x square cos x का बताओ. Same method यार, same method. Okay.
X into minus sin x.
Sorry, can you please repeat?
X into minus sin x.
Okay, that's it.
Yes,
Uh,
sir.
okay, no, see, you need to rewind a bit back. Okay, see, okay, there is some issue. Okay, see, Your y1 is x square, your y2 is cos x. Okay. So what will be your dy1 by dx? What will be this? What will be the derivative of this? Tell me, what will be the derivative of this?
2x
Yes, exactly, 2x. And of this?
minus sin x.
Exactly, minus sin x. So dy by dx is equal to y1 into dy2 by dx plus y2 dy1 by dx. ओके, एक का डेरिवेटिव दूसरे को कांस्टेंट रखना है, दूसरे को एज इट इज रखना है, और दूसरे जब दूसरे का लेंगे तो पहले को एज इट इज रखना है. ओके, लाइक दिस. So you
Okay.
are so you are keeping first intact. So it is x square multiplied by second. Second will be minus sin x plus y2. Y2 क्या है? Y2 is cos x multiplied by इसका कितना है? 2x. So this is your final answer. 2x cos x minus x squared sin x. This is your final answer. Okay? आया सबको समझ?
Yes.
Everyone got it? It's easy, right? It's easy.
Yes, sir.
Okay. So just if you have two functions, if you have two functions, you can just easily multiply the two functions. Sorry, like you can multiply the derivatives. It is just in the case if two functions are being multiplied, you have to do like this. Okay. Moving ahead, we have one more thing. Division rule. What does division rule mean? Division rule मतलब ये y है आपका. It is being represented by division of two functions, numerator and denominator. So how will you take derivative? It will be ऊपर वाला function into derivative of नीचे वाला minus opposite of this. See, if you guys are not able to remember this thing, please don't worry. Okay, you will be using these things for 2 years. Okay, for 2 years you will be using all of these things. You will be using it. So it is just a matter of practice. You will slowly be able to easily remember all these formulae. You will easily remember it when you will use it in physics, use it in mathematics, wherever you will. Okay. So no need to worry if you are not able to remember it currently. Okay. So see, I often like I used to study in Hindi, so I used to often remember it like uh, ऊपर वाले का डेरिवेटिव into नीचे वाला. Okay. Okay. I think I made a error over here. Okay, just a second. See, I'll give you one short rhyme also how you can remember it. See, it is ऊपर वाले का डेरिवेटिव into नीचे वाला माइनस नीचे वाले का डेरिवेटिव into ऊपर वाला डिवाइड बाय नीचे वाले का स्क्वायर. Okay, that's how I used to remember it during my time. Easy. Okay.
Yes, sir.
Okay, see, no, I am again telling you, no need to worry if you are not able to remember it. Remembering it is not an issue. Understanding it is not it is an issue. अगर समझ नहीं आ रही है ये चीज तो पूछ लो, बट ये मत पूछो कि सर याद नहीं होगा. याद हो जाएगा, 2 साल का टाइम है, बहुत यूज करेंगे इसको. दिस विल बी यूज्ड इन ऑलमोस्ट एवरी प्रॉब्लम व्हेन यू विल कम अक्रॉस इन मोशन इन स्ट्रेट लाइन. ओके. ओके. So yeah, so I'll just okay, so what did you not understand? Can you tell me what did you not understand? And by the way, we will derive it also. We will derive it when we will look into that part. When we go ahead with the chapter of limits and derivatives, we will derive how this division rule comes. How this derivative of y1 by y2 is this. We will do that. We will learn that. Okay. Okay, great. So just a practice problem for this also. Y is equal to, let us take x by sin x for your easy, because it is easy. Or take us x square. Okay, x square divided by sin x. Okay, how will you do that? What will be its dy by dx? So first of all, we will take y1. What is y1? What is y1 here? Gayatri, tell me, what is y1?
X square.
Okay. So Gayatri, how did that t come into picture in homework? Were you learning it from physics textbook?
I practiced derivations in physics in morning, sir.
Okay. That is why. Okay, I got it. I got your point. Okay, so what is y1? X squared, right? What is y2?
Sin x.
Exactly. So इसका डेरिवेटिव क्या होता है? What is its derivative? 2x, right?
2x. Yes, sir.
इसका cos x होता है. ठीक है? So now, if in case you are not able to remember this formula, you can see it right now. Okay. So ये क्या होता है? ऊपर वाले का डेरिवेटिव इंटू नीचे वाला. ऊपर वाले का डेरिवेटिव इंटू नीचे वाला माइनस नीचे वाले का डेरिवेटिव इंटू ऊपर वाला. सो नीचे वाले का डेरिवेटिव इंटू ऊपर वाला होल डिवाइड बाय डिनोमिनेटर स्क्वायर्ड, like this. So this is your final answer. Get it? Does everyone get it?
Yes.
Okay, great. Good to hear that. So okay, one practice problem for you now only. X raised to 4 divided by cos x. Okay, tell its answer to me now. Just now only we will solve it. Or you need to see this formula, it is here. Okay, tell me. Is it something that you are not understanding, or is it something uh, else? Like, see, I have seen your homework and you did all the problems correctly. So I'm pretty sure this will not be this should not be very difficult for you. Okay. Let me see who all are there. Rakshit, did you do the homework? Manaswini was not there yesterday, I guess. Gayatri was there. Bhavna was there. Bhavna, did you do it? किया था homework कल. Why are you not speaking anything? Omkar was there yesterday, as far as I remember. Omkar was there. Okay. So yeah, Gayatri, हुआ ये सवाल? Rakshit, did you get this? Gayatri, Rakshit, tell me. See, again, we will do the same thing. Y1 is x raised to 4. Y2 is cos x. So its derivative is, what is its
4,
derivative? It's
4x cube.
right. And iska?
Minus sin x.
Gayatri, you are comfortable with Hindi? Like,
Yes.
is everyone, first of all? No. Like, I meant to ask everyone only. ठीक है कोई बात नहीं. Like the trick I am giving, it is in Hindi ना, so it should मतलब वो समझ आना चाहिए कि मैं बोल क्या रहा हूँ. Okay, so what will be dy by dx? Tell me. If you have reached till here, you must have gotten this also. Tell me.
4x
हाँ
cube
बताओ. हाँ 4x cube.
cos x minus
Okay.
sin x 4 power x power 4
Okay, correct. Whole divide by.
cos x square.
Okay, great. Or I can write it as cos square x also, right? Okay, great. Great, great, great. Rakshit, क्या हो गया? Why are you not speaking? Okay, great. Okay, not an issue. So I'll tell you. Okay, so yeah. Okay, so this was the two rules we had learned: multiplication and division. We often come into another problem at sometimes. What happens is, uh, I have one function that is being written inside another function. Okay. So for example, if I take y is equal to sine of x squared. Okay. So what is happening, if you look at it closely, we had a function sine x, we had a function x square. So instead of this x, we are putting this function in this over here, right? You can easily recognize it. Okay. You can see what we are doing over here. We have a function f of x that is sine x. We have a function, another function g of x that is x square. And instead of this x, we are putting this function. So it is turning out to be something like f of g of x. You can see it is neither multiplication nor it is division. Neither you can use anything else. You can't directly substitute trigonometry also, because there is no trigonometric formula for sine x squared. There is no trigonometric formula. There is trigonometric formula for sine of 2x, sine of 3x, sine of 8x. But what will you do if one function is inside another function? How will we solve that? Okay. So is everyone getting what we are doing right now? ठीक है ना? समझ आ रहा है ना? See, you can't use multiplication over here. You can't use multiplication. Nor you can use division, nor you can use trigonometry. So we come up with the chain rule over here. Okay. There is a rule by the name of chain rule. Okay. What chain rule says is, if y, it is written as f of g of x. So dy by dx is equal to d. So instead of y, I will first of all write this. Okay. Okay. ठीक है. Divide by d of x. So it can be written as d f of g of x divided by d g of x multiplied d g of x divided by dx, because these two terms will get cancelled. That is how it works. So basically what that means is, see, the second term is very easy. Okay, second term is very, very easy. Second term basically means derivative of g of x. Derivative of g of x. Very easy. But if we look into the first function, it is telling me d of f of g of x divided by d of g of x. That means we are differentiating this combined function with respect to g of x. Okay. If I tell you, okay, I will show you with an example only. If I am telling you y is sine of x squared. Okay. I am asking you, okay, currently I will not write this y to confuse you. Okay. So what I'm asking is, if I am asking you to differentiate sine x with respect to x, what will be its answer? Differentiate sine x with respect to x. Its answer will be cos x, right? That's what we have learned now. That's what we have learned till now. So similarly, if I ask you to differentiate sine of x square with respect to x square, see, पहले x था और differentiate भी x के respect में ही कर रहे थे. So we get the answer cos x. Now we have sine x squared. We are differentiating with respect to x square only. What will happen here? Tell me. We have just changed the variable from x to x squared. Okay, we have just changed the variable. Earlier it was x, now it is x squared. So what will be its answer? Can I say
Cos,
that? Sorry?
cos x.
No, it will not be cos x. See, see. Earlier we had a function sine x. Okay, we were differentiating it with respect to x. We got the answer
Cos
cos
x.
x. Yes, exactly. Everything will change. Like earlier, everywhere we were putting x, now we will put x squared. We can just directly substitute x square in place of x. पहले x डाला था, अब x square डाल दिया, क्योंकि differentiation is happening with respect to x squared. Okay, so what does our chain rule say? Our chain rule says y is equal to f of g of x. Okay, so dy by dx will be equal to differentiate f and keep its internal part same, and then g dash x. Actually, this dash in top of any function also represents its derivative. Okay, it also represents its derivative. So what it is saying is you keep all the inside part of the function same. Like for example, I have sine of x squared. So it is saying you keep this part same. You just look at the outside part and differentiate it. So what was the uh, differentiation of sine? It was cos. So cos, and it is saying keep the inside part same multiplied by, now differentiate the inside part. So what is the derivative of x square? Tell me, what is the differentiation of x square?
2x.
Yes. So this is how chain rule works. So this is its final answer. Its final answer is 2x multiplied by cos square x. This is the final answer. Oh, sorry. Okay, it's not cos square x actually. It's cos of x square. Got it? समझ में आया सबको? This is what chain rule is saying. Chain rule, see, imagine it to be a chain like this, okay? A chain that is piled up jumbly on the ground. Okay, so if you are trying to pull it from one end, what will happen? पहले इसका एक पार्ट खींचेगा, फिर इसका सेकंड पार्ट taut होगा, the string will get taut, then its third part. So when its first part is getting taut, it is getting pulled, it is getting tight. So the second and onwards part do not change. They don't change. When you are pulling it from first, so the first bolt will get tightened. The all the other will remain in its position. Then the second will come. Then first and second both are in correct position. Then still the remaining part of the chain is as it is. Then we have third, still the remaining is as it is. So you can take a bit uh, insight from how this chain rule is working. Okay. Okay. I'll try to write it. Okay, great. Okay, so what I'm saying is, okay, so we will try this problem again. Okay, so it is sine of x squared. So first tell me which function. So it is a sine x, and inside it we are putting x square. You all see that, okay? So what chain rule is telling us? Chain rule is telling approach from the left side. Chain rule is telling me approach from left side. Left side means approach from the outermost side. See, inside sine x, we have put x square. So x square is inside of sine of x. So we will come from outer side. So what is our outer side? Sine x, the sine of this. So our outer function is sine. Okay. So it is saying first differentiate sine and keep all the other part constant. Okay. So it is cos, and it is telling me keep other अंदर वाले पार्ट को एज इट इज छोड़ दो, जैसे चेन में होता है। ओके, छोड़ दिया। मल्टीप्लाई कर दो, अब अंदर वाले पार्ट को डिफरेंशिएट करो। So it is 2x. So it is 2x multiplied by cos of x square. Okay, so we'll do one more problem on it. Y is equal to cos of x raised to 6. How will you do that? How will you do that? See, again same thing. Again same thing. वो बोल रहा है approach from left side. You are approaching from left side. Which function came to you first? Gayatri, tell me. I have come from left hand side. Which function I have met first? सबसे पहले मुझे किस फंक्शन से मीटिंग हुई मेरी?
cos x
कॉस के साथ हुई। कॉस का डेरिवेटिव क्या होता है?
minus sin x.
एग्जैक्टली लेकिन माइनस साइन एक्स नहीं लिखना मुझे। उसने बोला कॉस के अंदर जो भी चीजें हैं उसको एज इट इज नीचे,
X
एज
power
इट इज नीचे नीचे छोड़ दो। ठीक है, ओके। सो कॉस का पार्ट कंप्लीट हो गया। अब मैं ब्रैकेट के अंदर घुसा। ब्रैकेट के अंदर मेरे को कौन सा फंक्शन मिला?
x power 6.
ओके, एक्स पावर सिक्स का डेरिवेटिव उसने बोला एक्स पावर सिक्स का डेरिवेटिव करो। एक्स पावर सिक्स का डेरिवेटिव, व्हाट इज एक्स पावर सिक्स डेरिवेटिव?
X power
एग्जैक्टली।
6.
सो yes, this is its final answer. Minus 6x raised to the power 5 sine of x raised to the power 6. Okay, fine.
Yes, sir.
Okay, Rakshit, tell me, समझ आ रहा है? भावना, Manaswini, do you get what I'm trying, the point I'm trying to make? That it is very, very simple. You need not make it complicated. Okay. So yeah, actually, I just wanted to let you know limits and derivatives, that chapter, na, in 11th class NCERT book, uh, till only this much. Chain rule is only chain rule तक ही है बस, वो जितना है। Okay. So I have one last problem for chain rule. It is okay, sine to the power 8x. So it is sine to the power 8, not sine x to the power 8. Okay. How will you do that? So first see which function is being put inside another function. Tell me. Tell me which function is being put inside another function. See, we have this function x raised to 8. Inside that, we are putting sine x. Okay, you get that, right? So which is the outermost function? The outermost function is x raised to 8. Outermost function is x raised to 8. So chain rule is telling me start from outermost function. So what is derivative of x raised to 8? Acha, okay, yeah, actually no one else is speaking. Rakshit, are you there? Bhavna, Manaswini, are you there? Because I know Gayatri is understanding, so if I keep asking her, it will be like I won't get if others are understanding or not, because she's speaking also, she has done homework also. Gayatri, sorry, yeah, Bhavna, Rakshit, Gayatri, you know how we will do this?
Yes, sir. I can try.
Okay, tell me how we can go about it. Others are actually not responding, so I am not able to ask them. If
Sin
anyone,
power x, we can write it as cos x,
see,
the derivative.
okay,
Cos.
tell me how you will do. Tell me, tell me.
First, we'll take sin, no, sir.
No. Here actually the problem is twisted. See, earlier what was happening, you had the function cos x, and inside that function you were putting x raised to 6, which is the outermost function over here. Here the function is x raised to 8, and in that function you are putting sin x. So what is the outermost function?
X.
X raised to 8 is the outermost function, right? It will be x raised
Yes.
to 8. So what is the derivative of x raised to 8?
8x power 7.
8x power 7. Yes, correct. It is 8x power 7. But instead of x, we have put sin x. Instead of x, we have put sin x. Right?
Yes, sir.
So it will be, so see, what chain rule is
8
telling me.
sin.
Yes, exactly. It will be like this. See, what chain rule is telling me, when I approach from outermost side, so it is telling me first differentiate this function, but keep all its inside part same. Don't differentiate its inside part. And when you are completed with this level, now move ahead. Okay, so now we are moving ahead. I have completed this part. X raised to 8 वाला part मैंने complete कर दिया है अब यहाँ पे. I am moving ahead. So what function do I get after I move ahead? I get sin x, right?
Yes, sir.
So what is derivative of sin x?
Cos x.
Okay, great, great. Yes, so I'll do one more problem. Okay, see, these were problems like including two functions. Now it can be further also. Okay, so let me show you how it can be done. So let us take uh, sine of cos of x squared. Okay, right? You have this. So if you see clearly, sin x सबसे बाहर है, उसके अंदर मैंने ये फंक्शन डाला हुआ है, x की जगह पे मैंने cos x square डाला हुआ है. Cos x square is basically what is cos x square? Cos x square is basically this. It's three levels of problem. You see this, how it is happening? See, first I put x square in x. I put x square in cos x. Then I put this whole function in sin x. ठीक है?
Yes, sir.
है ना? This is correct, right?
Yes, sir.
Any issue in this part? See,
No, sir.
okay. So now what chain rule is telling me? Chain rule ने बोला approach from outermost function. Approach from outermost function. Which is my outermost function? Sin x. But it is, along with that, it is also telling me that when you are approaching from the outermost side, keep all the other things inside as it is, the way they were. So what will it be? Tell me the first, what will be the first term that will come? Anyone can tell, yeah. Okay. Bhavna, is there any issue?
Sir, is it 2?
No, it is not 2. See, which is the outermost function? First, get it. Which is the outermost function? I am approaching from left side. Which is the outermost function I am encountering?
Sin.
Yes. So what chain rule is telling me? You differentiate sine. So I differentiated sine. And then it is telling me whatever is inside the brackets, usko as it is यहाँ उतार दो. There is no change in that. Just copy it as it is. So it is cos of x squared. Okay. Now it is telling me you have completed this part. You have completed the first function. Okay, so move inside. What was inside it? It was cos of x square. Cos of x square. Now, which is the first function I come after I have completed sine? I come to cos. So what is the derivative of cos?
Sin.
No, it is minus sine.
Minus.
No problem. You will remember it. So what I have completed minus sine now. Now it is telling me that whatever was inside, whatever was put inside cos, just copy it as it is over here. Okay, so we are just following that bracket method system. First I encountered sine. So what did it tell me? कि यार sine का derivative करो. मैंने कर दिया. I did the derivative of sine. Okay. I'll change the pen over here. See, chain rule ने मुझे क्या बोला? चेन रूल ने मुझे क्या बोला, सबसे पहले जो फंक्शन आए उसका डेरिवेटिव कर दो। मैंने कर दिया। उसके अंदर जो भी चीज है ब्रैकेट में, जस्ट कॉपी इट एज इट इज। आई डिड इट multiply it. Now the next function that you encounter, the next function that I encountered was cos. Now I differentiated cos, and it is telling me you differentiated cos very good, but whatever was inside cos ka bracket, just copy it as it is. Okay, I did it. I moved ahead. When I moved ahead, I encountered x square. So it is telling me x square. Okay, good. So differentiate it. I did it. It is 2x. Is there any function inside x square? No, it is not. So it is, this is your final answer. Okay. So your final answer is this. This is your final answer. Okay. I hope you get how chain rule is working. It is a bit confusing in the starting. Okay. It is a bit confusing in the starting. Hello? Yes. Do you have a doubt?
No, sir, no.
Okay. Like, do you want to ask something? Or do you want to speak something? Okay. It is clear. Okay. I'm really happy. Okay. So see, chain rule is the toughest. I know that. Chain rule is the toughest of them all. Multiplication and those were very, very easy. So sine of cos of x raised to 6.
Again,
Sorry? Hello? Can you repeat?
sir, can you explain previous problem
Sure,
again?
sure. I will. Okay. So tell me any problem. You can use as many inside functions you want. You can keep it sine, tan, cos, and sorry,
Cos x of
cos of. Okay.
sin square x.
Okay. Okay. Great. Great. See, okay, not an issue. So what I'm saying is, see, so outermost function is cos x, right?
Yes, sir.
Inside that we have put sine square x. When I look at sine square x, it is basically x square, and inside that you have put sine x. Is this the correct order? Tell me, is this the correct order? Right now, inside first you will put sine x inside of x square, and this whole thing then you will put inside cos x. That is correct, right? Yes, chain rule is tricky. I do agree with it. Chain rule is tricky. Tell me. This order is correct, right?
Yes, sir.
Okay, great. So chain rule ने बोला approach from outermost side. Which is the first function you encounter? Tell me.
Cos.
Okay. तो उसने बोला see the first function you encounter is cos. तो उसने बोला cos को differentiate कर दो. Okay, I did it.
Minus
I
sin.
did it. Okay, I did it. But it is telling me कि cos के अंदर जो चीजें थी, everything that was inside cos, just keep it the same way. So cos के अंदर sin square x था, right?
Yes, sir.
Right? Okay. I did this part correctly. I moved ahead. So which is the
Yes.
function I encounter? Tell me. Which is the next function I encounter?
Sin
X
square.
X square, right? Yes, x square I encounter. So it is telling me differentiate x square. What is the differentiation of x square?
2x.
Sorry, x square?
2.
2x, exactly. But it is telling me whatever was inside 2x, whatever was inside x square at that time, just keep it like that only. So instead of x, I had put sine x. Instead of x, I had put sine x. So it will be 2 into sine x. Instead of x, I had put sine here, right? Instead of x, I had put sine over here. So it will be 2 of sine x. Like this. Okay. Okay. So after completing this part correctly, I moved ahead. This part done, this part done. So I finally came with sine x. So it is telling me differentiate sin x. What is the differentiation of sin x?
Cos x.
Exactly. So this, is there any function inside sine that we have put? Is there any function we have put inside sine of x?
No.
No. So it is telling me, okay, you can leave it at as it is. So this is your final answer.
Sir, may I know when we have to change the signs to minus or plus?
Yes, actually there is a trick for that also. I will tell you. See, every trigonometric function whose name starts with C, its derivative will have a minus sign in front of it. You can check it. Cos x, it is minus sin x. Uh, cot x, it is minus cosecant squared x. Cosec x, it is minus cosecant x into cot x. It is like a trick, you can say. And all others whose name starts with anything other than, oh, sorry, not cos, sorry, really sorry, not cos, sine, tan, sec. All these will have positive. Okay. Is this fine? This is a trick, okay? You can remember it.
Yes, sir, it's fine.
Okay. Okay. So are you guys comfortable with all this? Okay, so I'll give you six problems, okay? This is your homework problem. See, first of all, now that you are still practicing, I will tell you कि पहले ये ऐसा एक वेब चार्ट बना लेना that which function inside we are putting, which function outside it is, okay? Okay. So create something like this and then approach. Otherwise, you will get very, very confused. Because sometimes it looks that the function is sometimes it looks like the outer function is actually inside. Okay, I'll give you an example that we had done earlier also. Sine raised to the power 7x. Tell me which function is being put inside which function. Tell me which function is inside which function. Gayatri, Bhavna, Rakshit. At least
Sin
you can
x is
tell this.
inside 7.
Sin x is, hello, can you repeat?
Is inside.
Is inside which function? Is inside
Sir,
which
I
function?
think 7x.
X raised to the power 7. Yes, correct. Agar I have a function f of x is equal to x raised to the power 7 and I replace x by sin x. So it will be f of sin x. So I will get this function sin to the power 7x. Right?
Yes, sir.
Okay. So this I will first tell you कि अभी you are just starting differentiation. So initially you should do like this. You should first draw a flowchart like this, okay, and then proceed. Because you will get very, very confused. Because many a times when we see something like this, when we see something like this, we assume कि x raised to 7 के अंदर sin x डाला है. नहीं, that is wrong. That is wrong. It will lead you entirely to the wrong answer. Sorry, मतलब many people think other way around. Like sin to the power 7x है. So many people think कि sin x के अंदर x raised to power 7 डाल. No, it is not like that. It will turn out to be sine of x raised to power 7. There is difference between these two. It is sine x to the power of 7. Okay. I hope you guys get it. Okay. So yeah, I'll have a few practice problems for you. We'll be just doing these practice problems. Okay. So this is your homework for today. I'm not ending the class, just giving the homework. So okay, so तुम ही बताओ चलो. कोई भी एक जना. Tell me what problem you want to give. Okay, this is one problem. Okay, Gayatri, Bhavna.
Minus
Okay, tell
minus
me.
cos
Minus cos.
of.
Okay, tell me.
Sir, can I say tan
Yeah, sure, you can tell anything. Tan, okay.
tan of
Okay,
x to the power 10?
okay. Fairly simple. This is quite easy, right? Because you can just approach. Okay. Uh, okay, so one from my side also. Rakshit, you can tell one if you want. Are you there? You are still in the meeting? You haven't spoken anything today.
Yes, sir.
Okay, so चलो बताओ फिर कोई भी क्वेश्चन बताओ कुछ भी जितना as much complicated you want. Tell me. Okay. So कोई
So
नहीं.
cos into 3x cube plus,
Cos into 3x cube or cos of 3x cube.
sorry, cos of 3x cube
हाँ, okay.
plus 5.
That's it.
Yes, sir.
Okay. So I'll just trick this question a bit and I'll put a square over here. So it is cos square of this thing. Okay, I'll just write it after erasing it. The thing that Rakshit told, I am telling to square it. So it is cos square of 3x cubed plus 5. Okay. So okay, these are the fairly simple problems. These two will be bit tough. Okay. So the first function is x cube into sine of x raised to 4. Okay, the second is x raised to 10 divided by sine of x raised to 6. These are the two miscellaneous problems. See, one thing you will need to understand is uh, this function is getting multiplied by this function. This function is getting divided by this function. We'll be discussing these 6 problems tomorrow. Okay, you can have a note of these. And I think this like this UI also allows me to make a PDF of this thing that I'm teaching you now. I have purposely changed to this UI. This is app, so it will give me PDF also. So that also I will try to share to ma'am. Okay. Or do you guys don't need it? Tell me. जरूरत है इसकी PDF चाहिए?
Yes, sir. Please share it.
Okay, okay. I will.
It will be helpful for us.
Yes, I will. Okay. तो क्या थक गए हो अभी? जाना है या पढ़ोगे और? I have actually some few important things I wanted to teach today, but since we got stuck with it long, there is something. You tell me. वैसे मतलब मेरा तो प्लान यही है आज ही कर लेते हैं. बाकी how do you want it to be? Okay, is it? Okay, not an issue. Okay, if yes, anyways, my time has exceeded. So okay, not an issue. But then you will have to solve more problems. So tan raised to power 7x divided by, okay, not divide. Let's not divide it. It will be tricky. So tan to the power 7 of x to the power 5. Okay. Then we have secant square of x to the power square plus 1. Okay. Then we have uh, okay, tell me. तुम ही बताओ चलो. फंक्शन भी तुम ही बताओ. कोई कोई बात नहीं. Tell me any complex function you can think of. Tell me. Bhavna, Rakshit, you only tell. बता दो कुछ कॉम्प्लेक्स सा फंक्शन बना के बता दो यार. Okay, I will give it. Cosecant cosecant raised to power 3 of x cube plus 3x plus 1. Okay, so these are the 9 problems you will be solving for tomorrow. Fine. Hello. Okay, so yeah, that's it for my side. Okay, if you have any doubt in today's session, I am here to clear it. कोई डाउट नहीं है, सब कुछ समझ आ गया. Okay. Okay, ma'am, that's it. Thank you.
Yes, sir. Thank you, sir. Yes, students, again we will meet tomorrow at 6:30 p.m. Don't forget to subscribe our channel, Chatadhara Educational Technology.